I am Sukrut Kelkar and I am going to speak about Universal Serial Bus. USB, that is Universal Serial Bus. USB is a set of interface specifications for high-speed wired communication between electronic system peripherals and devices. USB offers users simple connectivity. It eliminates the mix of different connectors for different devices like printers, keyboards, mouse, etc. The topology used in USB is tree topology. The USB is actually an addressable bus system. It can support up to 127 different devices or nodes at once. The benefits of this topology is that power to each device can be monitored. Hot swapping. Hot swapping means that the devices can be plugged in and unplugged without rebooting the computer or turning off the device. Hub. Each hub routes the data from the host to its correct address and prevents bus contention clashes between other devices which are trying to send data at the same time. Single ports used to connect the host PC are known as the upstream ports. Ports used for connecting other devices to the USB are known as the downstream ports. Pipes. The logical channel connection from host to peripheral end is called pipes. All pipes are unidirectional. Connectors. The USB standard uses A and B connectors mainly to avoid confusion. The two types of connectors are shown in the picture. USB electrical signaling. The USB is a serial protocol and physical link which transmits all data differentially on a single pair of wires. Another pair of wires provides power to the downstream peripherals. In the circuit diagram, we can see the two differential links which connect the hub port and the USB port. USB communication. When a USB peripheral device is first attached to the network, a process called enumeration process gets started. This is the way by which the host communicates with the device to learn its identity and to discover which device driver is required. The USB communication takes place between the host and the endpoints located in the peripherals. An endpoint is a uniquely addressable portion of the peripheral that is the source or the receiver of the data. When establishing communication with the peripheral, each endpoint returns a descriptor. The descriptor is a data structure that tells the host about the endpoint's configuration and expectations. The descriptor includes transfer type, maximum size of the data packets, device address, and speed of the data device. Frames. Frames are series of bit times. Data transfer types. There are 4 types in which the data transfer in USB can take place: control transfers, isochronous transfers, bulk transfers, and interrupt transfers. Isochronous transfers. Isochronous transfer is used by time-critical streaming devices such as speakers and video cameras. It is time-sensitive information, so within limitations, it has guaranteed access to the USB bus. No error correction takes place in isochronous transfers because it is real-time transfer, so no point in checking as you have already sent the video or audio frame. Interrupt transfers. Interrupt transfers are used by peripherals exchanging small amounts of data that need immediate attention like mouse, keyboard, etc. Interrupt transfers use polling. The host always asks the port that do you have data for me? If the data is available, then the data is processed. USB packets and formats. Each USB data transfer consists of a token packet. which is the header defining what it expects to follow, an optional data packet containing the payload, a status packet which is used to acknowledge transactions and provide a means of error correction. The USB packets consist of the following field. The encoding which is used in USB is the NRZI encoding. USB packets. The USB packets come in 4 basic types, each with a different format and CRC field. The USB packet format is given below. It consists of 5 main fields: the synchronization sequence, the packet ID, the packet specific information, the cyclic redundancy check, and the end of operation field. Handshake packets. Handshake packets are generally sent in response to data packets. The 3 types of handshake packets are acknowledgement, which indicates that the data was successfully received; not acknowledgement, indicating that the data cannot be received at this time and should be retired; stall, which indicates that the device has an error and will never be able to successfully transfer data until some corrective action is performed. Token packets. Tokens are only sent by the host, not by a device. There are 3 types of token packets: in token, which informs the USB device that the host wishes to read information; out token, which informs the USB device that the host wishes to send information; setup token, used to begin the control transfers. Data packets. There are 2 basic packets, data 0 and data 1. They must always be preceded by an address token and are usually followed by a handshake token from the receiver back to the transmitter. The maximum data payload size for different speed devices are given here. Pre-packets. Low-speed devices are supported with a special PID value, pre. This marks the beginning of a low-speed packet and is used by hubs which normally do not send full-speed packets to low-speed devices. Start of the frame packets. Every 1 millisecond, the USB host transmits a special start of frame token. This is used to synchronize isochronous data flows. Start of frame packets contains an 11-bit incrementing frame number in place of device address. Now let's see how the transfer between the host and the target takes place. Firstly, data is sent in alternating data 0 and data 1 packets to facilitate error recovery. The host sends an out signal to the target. When the target receives this out signal, the target understands that the data is coming. The host then sends a data 0 packet to the target. As initially toggle bit in target and host is 0, after receiving the data 0 packet, the target toggles its bit 0 from 0 to 1, and after confirming that all the error checking and everything is okay, the target sends an acknowledgement back to the host. Host then changes its toggle bit from 0 to 1. Now the host sends a data 1 packet to the target. After receiving this data 1 packet, the target checks for errors, and after confirming that everything is okay, the target sends an acknowledgement signal to the host. Before sending the acknowledgement signal, the target changes its toggle bit from 1 to 0. The host, after receiving the acknowledgement signal, changes its toggle bit from 1 to 0. This is how the transfer between the host and the target takes place. These are the versions of USB which were released. The latest development is the use of optical fibers for the data transfer. I conclude here by saying that there is more to come. Just take a back seat and wait for it.